So if you're interested in heat treating, I would suggest that you go all the way to the end of this video, and I'll show you a very interesting, a very different and unique style of controlling how you draw the temper back into a piece. Hello YouTube, Jerry Kirkpatrick here. This morning I got up early expecting to go to the Good Guys car show. Just as I was about to leave, I decided I would spend a Saturday and make this heat treating video. So while I was gathering all of the pieces to do the demonstration, the mail carrier came in, delivered me a small package, and in that package was this: 2 t-shirts and a very nice letter from Ron Covell. So thank you very much, Ron. Sorry I missed you in Pleasanton this weekend. So now for the heat treating. I started blacksmithing in 1973, and for 13 years worked strictly with coal, a coal-fired forge. So the context for those statements is that in blacksmithing we speak primarily in color. Color of the forge, color of the material that we'll be working, the color of the material as we're heat treating. So color is a primary way that blacksmiths speak to one another. So having said that, the sum total of my heat treating analysis system is my eye and a single cut file. With the file, I can determine the hardness of material. You have file grab, which is a very soft material. You'll actually remove material as you file. File touch is a little bit harder material. You'll file, but you're not going to remove much material, and you'll have a little tingy sound as you file. And then the last one is file skate. File skate is when the file itself will not cut into the material, and you can feel it just skate right over the top of the harder materials. And by eye, what I'm talking about is heat ranges, forging heat ranges, and then hardening, tempering, and drawing the temperature in different colors. So for forging a mild steel, we can get down into the reds at the very least. You want to start up into a bright yellow, and then you can work the material until you get down into almost a bright red. Dull red is getting hard to work. You're better off stopping your forging in this area, bring it back up to heat, and you'll get a lot more work done. As you can see here, at 1,000 degrees, we're at just a red, and in blacksmithing we call that a daylight red, and you have to actually hold it in a bucket in order to see that you have any color whatsoever. with a high carbon steel, you'll stop forging right around the orange and bring it up to somewhere around 2600. Steel melts at 2700 degrees. So if you work your material down into this range, you're not getting anything done. So as you can see, with the higher carbon steels, you have to maintain a very high heat range. So over the years, I have forged many different materials, all the way from the softer materials up to probably 0.2% carbon, and have had the necessity to heat treat them. So let me show you a few of those. This is a gate holdback that I made. I made 7 different gates for a winery over in Napa, and I needed this spring, and obviously you're not going to find a spring like that. So I found a rear spring, coil spring, off of a motorcycle and forged it to this thickness and then cut it to this width, formed it into the shape necessary, and then heat treated it to get the springiness in there. And when the gate opens, it pushes this down. The gate is captured in here, and when you want to release it, you just touch it with your toe and the gate can be swung closed. The customer wanted these because his gardener was opening all of his gates with the wheelbarrow and knocking the finish off. So I had to make 7 of these different ones. This one was mounted on concrete, and I had other ones longer that were actually set in concrete right beside the walkway. Here is just, as you can see, rebar. I was teaching a split and drift class over in Berkeley, and we gave all of the students just rebar to make their chisels, their walking chisels and slitting chisels out of. And I was so impressed with the temper that I could get in this material. I went over to his stock and found one short section that had Korean right in the piece, and you can't see much of the temper range in there. I'll show you a little bit later the tempering colors, but that just goes to show you that you don't know what the material is going to be, how it's going to react to tempering, until you temper it and then draw the temper back. One excellent tool or piece for making tools out of is intake valve stems. All of these are stem that have been forged. There's a chisel, 2 punches, and this one was made for doing hot collars, putting pieces together. Now this one, I think you can see the color range. Starting here, this is the highest temperature. This, if you draw the temper back to like a peacock blue, you're going to get a spring steel. And then the darker straws, the harder, the more brittle the piece is going to be. So when you temper a piece, it's going to be as hard and as brittle as that material can be. As you draw it back into different heats, you're going to get the stresses in the material relieved, and until you get back all the way to a purple. Once you get past this, you've lost your temper. And if I file this end, you can hear how it grabs. There, it's a file touch. You can hear the difference in that. And then we get to the edge, and that's a file skate. You can hear it just rubbing right on top of the piece. It's not cutting at all. Now for tempering a hammer, the way I do it, the way I was taught many years ago, is you'll get the whole piece up to its austenitic range, where a magnet will no longer touch the material. It won't take the magnet. And then on this particular hammer, I quinched down about maybe a ½ inch and kept that in the water until the piece would hold water still. You dip it in, pull it out. If the water evaporates immediately, you put it back in until when you pull it out, water will stay on it. So you have this part, just the face, this much, heat treated. It's as hard and as brittle as this piece can get right in this area. So you turn it up and watch the face of the hammer, but the heat that is retained in the body will start to come back up, and you'll slowly see the face start to get up into the straws. So as soon as you see this whole face almost a dark straw, then you will run a small stream of water, and the size of that stream is determined by the mass. I had about 1/8 of an inch stream of water running in here, and it would cool that at that dark straw. As the water would bounce off, it'd go out farther and farther and farther. And if you get that stream of water right, by the time that stream of water gets all the way to the outside, this edge is purple, which is spring steel. So you have a nice hard and resistant center, but if you have a misblow and you hit the edge of the anvil, which is a very hard surface, you're not going to chip your hammer off, because this outer ring is spring steel, and as you work in, it gets harder and harder and harder. So the hardening and tempering of material, the way I do it, is in no way what you would call the approved method, but it's the way it's been done by blacksmiths for thousands of years. We don't have a heat gun. Everything is done by eye. So before I light this thing off, I'm going to take a few fire brick of different shapes, the broken ones, and place them towards the back of the fire and try and, or the back of the forge, try and fill that whole area up to decrease the volume that I have to heat. And the next thing I'll do is I keep in the back here a magnet, and anytime I'm doing any heat treating, I just hang that on the front, and when I get to an austenitic range where the material is no longer magnetic, I can pull it out, touch it to the magnet, see if I have reached the non-magnetic range, and then do the quenching. And next, by using my digital thermometer, I'm going to check the temperature of the quenching fluid. Okay, so I've got all of the bricks placed the way I want. Bricks way in the back, so it decreases the volume that I have to heat in there. And then I have two other bricks laid down in there, so I can take my special poker, put the pieces in, and there's a slight space in between them, so I can work the pieces off. So let's get the forge started, and we'll bring it up to heat. This one will take a little bit longer because there was more mass in the part. An old blacksmith told me one time how you know if you got the right heat. You just count the bubbles in the oil. So there you have it. You can see that there's scale on the outside. So give me a chance to bead blast these, wire brush them, and then polish them, and we'll be ready for drawing the temper. So here are the parts after they came out of the heat treating oil. And here they are after being sandblasted. And at this point, the parts are as hard and brittle as these parts can be. Whatever the molecular structure is, the degree of carbon and other compounds that are in it. And you can hear the file just slides right on the piece. It's not taking any material whatsoever. So now I'll wire brush them and polish them on the lathe, and we'll be ready to draw the temper. You have to remember, we're only halfway done at this point. And here they are after being polished. So I've had the forge going for a short while. I'm going to put the larger of the two in. And turn the forge off. And now just wait for the heat to come. I think we can do it right about there. Now I'll go a little more. I'm going to relight the forge. And we're there. And you can see that we're just at I wouldn't call that a light straw, we're just working into a dark straw, and that's exactly what I wanted. So you can see how careful you have to be with watching your colors. You can't tarry at all. Now for the smaller piece, I've got a piece of 1/2 by 2 hot flat bar in the forge getting hot, and a piece of tubing that is just about the same diameter as the smaller of the two dies. So I'm going to take the 1/2 by 2 out. As you can see, it's almost red hot. And I'm going to take the piece of tubing out and set it up right there so I retain a bunch of heat. I'm going to take the smaller of the two dies and bring it up to heat. And there. Now I'm going to take it and put it on that piece of tubing and hope the outside edge, yeah, you can see it's starting to turn blue out in here. With this extra heat from the tube, it's inducing through contact. Oh yeah, you can see it turning blue in here. This is great. This is going to be great. Got a little more right here. And waiting for that little bit right there. I'd say that's good. And once again, we're keeping the piece moving so we don't get any bubbles. I think we're just about done there. Oh yeah, that's looking great. Cool it off a little bit more. And there you can see the purple on the outside here, and we still have a dark straw in this area. So that's exactly what I was after. So we have a like a peacock blue on the outside going to a darker brown on the inside. So we have a little springiness on the edge and still tough in this area here. So there's how to heat treat a couple of bead roller dies. So I hope you found that interesting. Heat treating or drawing actually the temper on the larger block. You can see I got a nice brown color which softened the piece up. It allows it to take a little bit more abuse without cracking or breaking. And on the smaller piece, it was a fairly unique way of drawing the temper to the outside. And here you can see that the outside edges are a nice peacock blue with the browns in the center. And that was exactly what I was after. We have a little bit more springiness in the outside edge, and then still hard and tough in the radius here, as opposed to hard and brittle. So if you like this, please give me a thumbs up. Don't forget to subscribe. See you later.